Welcome to Geometry. In this video, we're going to look at Chapter 19, Section 2, and it covers the volume of pyramids and cones. And as always, we start with a warm-up. An aquarium is 40 centimeters long, 20 centimeters wide, 25 high. What is the volume of the aquarium? Remember, our general formula is area of the base times the height. And since it's a rectangular prism, we can replace the base with length times width and then multiply that by the height. So if I plug in the numbers from the picture, we're going to have 40 times 20 times 25, and the calculator eats those up and spits out the answer of 20,000, and we would attach the units centimeters cubed. All right, and today we're looking at pyramids and cones. So we have a picture here. Our base of this pyramid is 230 by 230. Height of the pyramid is 147 meters. Example 1, use the diagram and the lengths of each side to answer parts A through C. So part A, find the volume of the rectangular prism, and that is going to be exactly what we just did in the warm-up. We're going to multiply the base, 230, by 230 because our base is a square, and then the height of it is 147. We multiply those together and we get a pretty big number, 7,776,300, and our units would be meters cubed. Part B, would the volume of the pyramid inside the prism have less volume or more volume? Well, we can see the pyramid inside the prism, and there's a lot of stuff in the prism that's not in the pyramid. So the pyramid is going to have less volume than the prism. So part C is about a guess. If we had to take an educated guess, with how much less or more volume would the pyramid contain than the prism? In each of my classes today, the first guess was a half, and then I said it's a little less than that, so they went from a half to a third. And that is not just a guess, it's actually the correct answer. Part D, the actual volume of the pyramid is this 2 million and change. How does this compare to the volume of the prism? So if we take the volume that we found up top, our 7,776,300, and we divide it by our estimate from part C, if we divide by 3, when we do the division, it turns out to be the 2,592,100 meters cubed. Something else we did in class is we got out the big TI-89 graphing calculators, and I made the 2,592,100 the numerator, and then the denominator was the 7,776,300, and those calculators reduce fractions, and this perfectly reduces down to 1/3. All right, and now that's going to lead us to our volume of a pyramid definition here. The volume V of a pyramid with base area capital B and height H is given by this formula. 1/3 area of the base times the height. Again, make sure that capital B, you always think of it as the area of the base. All right, let's take our formula for a test drive here. We've got a couple. The first one is a pyramid with a square base. The second one is a pyramid with a triangular base. So our volume is capital B times the height of the pyramid. And again, I can change that capital B into length times width, and that gets multiplied by the height. And in this case, our length is 15, and our width is 15, and our height is 10. Ooh, I forgot my 1/3. Shh, don't tell anybody. So there's the 1/3 in the front. So we're going to have our 1/3 times 15 times 15 times 10. And we just punch that in the calculator. Everything in the parenthesis is going to multiply to 2,250. And 1/3 of that is a nice even 750. Our units are feet, so that will be feet cubed, cubic feet. All right, now the next one here, the copier didn't do a good job in the notes. I'm going to highlight here in red our base of this pyramid. And notice these two sides here, they do come together to form a right angle. And then we have this would be the hypotenuse of that triangular base. And I'm going to sort of draw that off to the side here. Here's our right angle. The 6.1 and the 8.2 sides come together to form that right angle. So our base is a right triangle. Our volume formula, again, is area of the base times the height of the pyramid. Now, I can change this capital B into the area. Oh, I forgot my 1/3 again. I'm going to change that capital B into the area of just a triangle. And that is 1/2 base times height. And then we've got the other height, which is the height of the pyramid. So it might be a little confusing with the two heights in there. But let's start plugging and chugging here. I've got my 1/3. And then inside the parenthesis, I'm going to have, here's my triangle's base and height. So I'm going to have 1/2 times 6.1 times 8.7. And then we multiply that by the height of the pyramid. And that here is the 5.7 in the picture, 5.7. So to make this a little easier on the calculator, I would multiply these fractions together first. 1/3 times 1/2 is 1/6. So we've got our 1/6 there. And then if we multiply the 6.1, the 8.7, and the 5.7, that should multiply to 25.01. And we're going to multiply that 25.01 by the 5.7, and then we'll divide by that denominator 6. And we should get our exact volume is 47.519. Units are centimeters, and they'll be cubed. All right. In example 3, it's kind of like an applied one. We've got a crystal. The crystal is cut into the shape formed by two congruent square pyramids, and then we join them together at the base. The mass of the crystal is 3 grams. We will at the end find the density of the crystal in grams per cubic millimeter. And then bolded here is how to find density. Density is just mass divided by volume. So this is sort of broken into pieces. Part A, it says find the volume of one of the pyramids. So our volume formula is 1/3 capital B times the height of the pyramid. In our picture, I'm going to highlight here, let me get my red ink out. This is one edge of our square-based pyramid, and that edge is 7.2 millimeter. So the area of our base is going to be 7.2 squared, and then we're going to multiply that by the height 5, and of course we've got our 1/3 out front. So that's going to be 1/3. If I square the 7.2 and multiply by 5, I get 259.2. And if I divide that by 3 for the 1/3 fraction, I will get 86.4. Units are millimeters, and they will be cubed. So that's the volume of one pyramid. Part B, find the volume of the whole crystal. Well, the crystal's made of 2 of these pyramids, so I'm going to multiply by 2 my answer from part A, 86.4. And if I multiply those, I should get 172.8, and our units are still millimeters cubed. All right, now the last part, find the density, and again, that's the last sentence in our problem description. That is mass divided by volume. Well, the mass was given to us. That's right here, 3 grams. So 3 divided by the volume that we just found, 172.8. If I divide that out, I get approximately 0.017. Now, our numerators were in grams. Our denominators were in millimeter cubed. So when we divide those, our answer here is numerator units, grams, per denominator units, millimeter cubed. And that is what they asked us for up here in the description. Find the density of the crystal in grams per cubic millimeter. There's our grams per cubic millimeter. So we've done 3 examples. We're going to pause here a little bit in the middle, pause the video, try practice problem 1A and 1B, And then after you get your answers, start the video up again and see if you got the same answers I did. All right, in the first one here, notice they did give us the area of the base was just handed to us. So in our volume formula, 1/3 capital B times H, the capital B is the 24. And we're going to multiply that by the height of the pyramid, 16. If I multiply straight across, I should get 128 cubic inches. Okay. In letter B, it's a pyramid. Our base is just a square. So our volume is capital B times H. That capital B, the area, oop, I forgot my 1/3. The capital B is the area of our base, and our base is a square. So I can just put 12 squared in here. And then the height of our pyramid is 5. So I would do 12 squared, that's 144, multiply by 5, divide by 3. Hopefully, you've got 240. Our units would be centimeters cubed. Okay, so there was a little break and a little bit of practice. Let's get back to the lesson. We can approximate the volume of a cone by finding the volume of an inscribed pyramid. So let me make this picture bigger. So if I look at the first one, I've got a cone. I want to figure out the volume of the cone, and the first thing I put in it is a triangular-based pyramid. And then, of course, the cone will have more volume than the pyramid because there's this area in here that we're not counting. It's in the cone, but not in our pyramid. So if a 3-sided pyramid's good, let's up it to 4 sides. Now the pyramid is bigger and it takes up more volume of the cone, but again, the cone is still going to be a little bit bigger. So if 3 sides was good and 4 sides was better, we could try 5 sides. Now we've got a 5-sided pyramid. Again, the area in the base that's not in the base of the pyramid is smaller, so we're getting closer and closer to the true volume of a cone. We could keep doing this with 5 sides, 10 sides. We could do 100 sides. We could do 1,000 sides. The more sides of our base, the closer we get to the real volume of that cone. So the volume of a cone here with base radius r, so our base is a circle, of course it's going to have a radius, so our base radius is r, and our base area, capital B, would just be pi r squared. And the height of the cone is h. The volume of our cone, this should look familiar, 1/3 area of the base times the height. Again, this is just like what we saw for the pyramid, 1/3 area of the base times the height. But in this case, the capital B, area of the base, we can replace with pi r squared because our base is just a circle. All right, in example 4, we've got an ice cream shop with a large decorative cone out front. What is the volume of the cone? If I blow the picture up so we can see it a little better, the diameter of the cone is 3 feet. So that means the radius of the cone will be half that, 1.5. The height of our cone is 4.5 feet. And now we can start plugging into our formula. Again, our basic formula is capital B times H. But I'm going to take out the capital B and replace it with pi r squared because our base is a circle. And we'll multiply that by the height. So if we start plugging in our known values, we got pi. The radius is 1.5, and we're going to square that. And our height is 4.5, and we're going to multiply and then multiply that by pi. Oh, I did it again. I forgot my 1/3. 1/3. So we're going to square the 1.5, multiply by 4.5, times it by pi, and divide it by 3. And that should be, without the pi, it would be 3.375 pi's. And then we multiply by the pi key, and we get approximately 10.6 feet cubed. So there's the rough volume of that giant novelty ice cream cone. So that was part 4A. Now part 4B, it says a second cone with the exact same dimensions as the first one is added upside down onto a cylinder. The cylinder has a diameter of 3 feet and its height is 2. So here's our cone diameter. That was 3, so the cylinder diameter will have the same diameter. And then the height of our cylinder is 2. So if we want to find total volume, that's going to be the area of the cone plus the cylinder. And the volume of the cone we just found in part A. So this we can just replace with a 10.6. And now we're going to add the volume of our cylinder here on the bottom that I just circled in red. And the volume of a cylinder is pi r squared times the height. Well, pi is just pi. Our radius, just like for the cone, is 1.5, and we're going to square that. And we're going to multiply it by the height of that cylinder, which is 2. So again, always bring down our 10.6. And then if we multiply 1.5 squared, that's 2.25 times 2 is 5.5, or 4.5, excuse me. And we're going to multiply that by pi. So, well, let's just do it like this, 4.5 pi. So in my calculator, I would do 4.5 times pi, and then add 10.6. And then if we round that off, that should be roughly 24.74. Our units, again, are feet, so that will be feet cubed. Remember, the cone from part A was 10.6, and then we added the volume of that cylinder, and we got our total volume. All right, here will be the rest of the practice problems for the section. So again, pause the video, start it back up after you get your answers, and compare them to mine. So let's see here, Julian is making candles. Each candle has the same volume. The dimensions of the candles are shown. If he has 200 cubic centimeters of wax, how many candles can he produce? Well, if we look at this, I'm going to sort of color code. We have volume. The volume of the cone on top I'm going to do in red. So the volume there is going to be 1/3. And then we're going to have pi r squared times the height. And then we're going to add, I'm going to switch to blue ink. We're going to find the volume of this cylinder. And that's going to be pi r squared h. For both of these, the diameter is 3 centimeters, so our radius will be 1.5. And up here, we are going to need the height of just the cone, so this red line that I'm drawing in. Overall height is 6.5. Cylinder height is 5. If we subtract, we should get the height of the cone is 1.5. So back over here, again, color-coded. We have our 1/3, so we're up on the cone. Pi is just pi. Our radius there is 1.5, and we're going to square that. And then we're going to multiply that by the height, which is also 1.5. And then we've got our blue cylinder. Again, there's pi. Radius, again, is still 1.5, and we're going to square it. And the height of the cylinder is 5. Again, I'm just going to stay with the red stuff here. If we compute that, we should get 1.125 pi. And then the blue stuff, we are going to add to that 11.25 pi. If we add those together, we get 12.375 pi. And as a decimal, if we multiply that by pi, we get about 38.877. Our units, again, are centimeters, and would be cubed. So if he has 200 cubic centimeters of wax, let me erase up here, get a little more room. So he's got a total of 200 cubic centimeters. Each candle is 38.877. When you divide that out, you get roughly 5.14. So in a case like this, in this applied problem, we would round down. Nobody wants 0.14 of a candle. So we can say he can make 5 candles with the wax that he has on hand. All right, number 2, part A. find the volume of the cone. First one should be a piece of cake. Our volume is 1/3 pi r squared h. In this case, they just gave us the radius. The radius is just 13. And the height is 27. So order of operations, I would square 13, multiply by 27, divide by 3, and then multiply by pi. If you leave pi in your answer, it should be 1521 pi. And then we multiply with the pi key, and we get approximately 4,778.4. In this case, our units are inches, and that will be inches cubed. All right, now the next one looks like it's going to be just as simple as the first, but there is a little twist in this part B. The 16.6 given in the picture is the slant on the edge of this cone. So what we need is this height inside. So if I put a right angle here, obviously we've got a right triangle. The base of our, down here, this is our diameter, so we would have to cut the 12.5 in half. So that's going to be 6.25 would be our radius. So the radius, I'm going to sort of draw a little right triangle over here. The radius here at the bottom would be this 6.25. The 16.6 is our hypotenuse, so we would need to use Pythagoras to solve for this height. So if I write it out, we would need 6.25 squared plus the height squared is equal to the hypotenuse squared. And if you do all the work on that, you should get the height is approximately 15.378. So I'm going to erase this. Height here is 15.378. And now we have everything we need, the radius and the height, to use our volume formula. 1/3 pi r squared times the height. So we're going to have pi times 6.25 squared, and then that's going to get multiplied by the 15.378. And the 1/3 is still lurking out there. You could just put a divide by 3 over all of this. And when we punch that into our calculator, we should get approximately 629.1 yards cubed. All right, we just got a couple more to go here. These can be a little trickier. We're working with some composite figures. So find the volume of each composite, round to the nearest tenth. And it looks like in the first one, we want the area of the cylinder, and then we're going to carve out the cone. So for this one, let me do it like this. We want to do cylinder minus the cone inside. So let's just keep this in the raw, pure formula format. So the formula, or the volume of our cylinder is going to be pi r squared times h. And then we're going to minus the cone 1/3 pi r squared h. Now we could very easily plug in the r and the h into this formula, and it would work out nicely. But there is another way to look at it. In front of here, I would have a 1. And if I put brackets around all of this, I could say, okay, what's common that we could factor out of each term? Well, each side has a pi. So let's factor out a pi. There's an r squared in the first term. There's an r squared in the second term. So let's factor out r squared. We do have an h in the first term and an h in the second term. So let's factor out the h. And then if I put some brackets here, what's left? Well, we factored out this pi and r squared and h, so we're left with a 1 minus, we factored out pi and r squared and h, so there would be a 1/3 in there. What is 1 minus 1/3, or 3/3 minus 1/3, is equal to 2/3, and then we're going to multiply that by pi r squared h. Pi r squared h. So again, we could have plugged everything into the original formula there that I'm erasing right now, or we can now just plug it into this and get our answer, get our answer right away. Oops. Let me move this up. Okay, in the picture, r is 7, h is 14. So 2/3 times pi times 7 squared times the height, 14. So in my calculator, I would do 7 squared, multiply that by 14, multiply that by pi, multiply by the numerator 2, and then divide by denominator 3. If all goes well, you should get 1,436.8 feet cubed. Okay, one more to go. And this looks like we've got a cube on the bottom, 7 by 7 by 7. And on top of that, we have a square-based pyramid. So our total volume will be cube plus pyramid. Well, the volume of our cube is going to be length times width times height. And then for the pyramid, we're going to have 1/3. Area of the base will be length times width. Now here we're going to have another h, so we got to be careful. The height of our cube is this red line 7. The height of our pyramid will be the blue 11. So we got to be careful when we're plugging here into our formula. So the volume is, the cube is easy. Length times width times height is 7 times 7 times 7. And then we're going to add to that 1/3. For our pyramid, the length is the same 7. The width is the same 7, but now here the height is 11. Boom. So if we multiply that out and we start adding stuff together, if you kept pi in your answer, you would have 200.24 pi. And if you use the pi key, that would be approximately, back. I was looking at the wrong spot on my answer key. That would be, well, just jump right to the final answer. 522.7 inches cubed. Yeah, where was I getting the pi from? There's no pi up here. So this stuff multiplies to 343. And then this is 539 divided by 3. Again, final answer, 522.7 inches cubed. All right, that's the end of the video. I hope you found it helpful.